Mm. What's up, YouTube? How's everybody doing out there? This is Greg from Greg's Tutoring NYC. Hello there. Peace in. Hope everybody's having a good week. I'm a tutor here in New York City, and we should have just gotten through our New York State tests, which is where I'm sourcing some of these hardest math problems from. So I went through back past years and looked up the problems that most kids had errors and problems with, and I got them all together on one pile. So that's what we're doing here. We're on part 5, I think, of the grade 6 math problems. I did grade 3, grade 4, and grade 5 as well. So there's a ton of hours of videos out there already. If anybody wants to try to kind of reorient themselves in some of this. So if you're in grade 6 now, you should probably go through the grade 5 videos as well. And when I get to the 7 ones, you should probably look through some of those as well, because you want to be not just at grade level, but a little above. So at any grade you're on, you should also know the material below it, right? So there's that. Um, on that note, I'm trying to take the perspective that I'm not doing test review here, even though these are sourced from a standardized test, and even though they're going to be very useful if you're preparing for the New York State test, obviously, but any state test of any city or state, because grade 3 math is still grade 3 math. Give or take a subject or two that one curriculum or standard might move back and forth to a different year. Okay, so but for the most part, you know, multiplication and stuff like that, or basic core arithmetic is going to be like the focus of grade 8. And as you move towards grade 3, sorry, and as you move toward grade 8, it's going to move more into algebra and other trigonometric things and geometry and those kind of things like that. So standard fare here. So the problems at this grade are going to be harder than the ones I went through grade 3. And when I go over the grade 7, 8 ones, they're going to be harder than this. What I want you guys to get out of this is not just trying to prep to pass a test. In fact, that's the least consideration I have. Even though you can use this to do that, and there's other tests coming up, like when I do the grade 7 and grade 8 stuff, it'll be totally applicable as your prerequisites to studying for things like the SHSAT, the ISEE, the SSAT, the Bergen County test, and even other cities like Chicago has selective high schools, Boston has selective high schools, and international as well. There's other places like New South Wales has selective high schools as well. And there's also gifted and talented entries at middle school and different things. So it depends what accelerated program or whatever you're trying to shoot for, honors programs. And that's really the goal of this, is to kind of test your brain and get you to interact with math problems and think them through and do problem solving, things like that. So that's the goal here. It's not to go through problem 1 and problem 9 and figure out how to game that. There's no gaming here. It's about thinking things through and breaking problems down and doing critical thinking, and also using your numeracy to be able to adapt to any problem that's thrown at you. All right. So that's the key. The key isn't knowing perfectly how to solve problem number 5. The key is being presented with problem number 5, never having seen it before in your life, and still being able to rip it apart and figure it out. Okay. All right. So with that in mind, that's where we're going to go. All right. So let me make sure we're live. 1 second. All right, yeah, we seem to be. By the way, again, I'm Greg from Greg's Tutoring NYC. My email is floating across the bottom of the screen. Please subscribe to the channel, because I'm always pumping out new content. Please like, that helps the channel as well, and indirectly, therefore, it helps you guys. In fact, if you go to GregsTutoringNYC.com/gift, if anybody wants to do a donation to help support this channel, it's being offered to you guys for free, but I would be very appreciative and gracious if anybody could do that. Okay? Not anybody, everybody, right? So, all right. So with that in mind, let's jump into the remainder of the grade 6 problems. So I ended up here the last time, Let me set up my pencil. I'm going to go through this real quick because I said I had yesterday when I did this problem, I mentioned that I have YouTube's live streams already that has covered extensively least common multiple and greatest common factor, which is the two topics of question number 44. But I'm going to go through this real quick here to show you another technique. A lot of you probably know how to do this as prime factorization. There's a way to do this combinationally at the same time. So if I take choice A, I have 6 and 10. Let me fix that 6 a little better. Okay, so what I'm going to do is write the two numbers next to each other, and I'm going to go put a line over here and a thing underneath this. Now, when you're going to do division, normally when you do division, you're going to do something like this, like 106 or something. And then you're going to write the answer on the top. So this would be 53. So in this case, we're going to write the answer underneath it. So what we're going to do is try to find basically the smallest prime number, more or less, that divides into both of these. First of all, you need to see the factors and figure out the smallest factor is basically what it comes down to. And that's hopefully going to be a prime number. So that's what you want on the outside is prime numbers. And if you remember, a prime number is a number that has no other factors except 1 in itself. So 5 only has the divisors of 1 of 5. 6 has 1 and 6, but it also has 2 and 3. And so on and so on and so on. So what we're going to do is, we notice that 2 is a factor, both of these. So we're going to divide 2 into 6 and get 3. And we're going to divide 2 into 10 and get 5. Okay? It turns out all we're left with now is prime numbers on this line here. Okay? So we're done. We're done. Okay? So let me just do 5 and 12. Or let me do 10 and 12. Just to show you the technique. Okay? So we're going to do the same thing here. 2 is a factor. So we're going to go 5 and 6. Okay? So in the example I just gave, the 3 and the 5, those are primes. So that's one reason why we stopped. But the reason we're going to stop at the 5 or 6 with this example is because there's no common factor of the both of them. Okay? And then we're going to do 12 and 15. So the smallest common factor between the two of these is 3. So 3 goes into 12 4 times. 3 goes into 5, 15, 5 times. And then we stop again because there's no common factor of 4 and 5. Okay? So let me put on the side. This was A. This was C. This was D. And I saved B for last. So B is just going to be 5, 12. So it turned out there's no common factor there except for 1. And when you do 1, you're left back with 5 and 12. So you're done. You're done. So what we have now is the greatest common factor of each 4 groups of these. So let me change the color of that. So this 2 here is the greatest common factor of 6 and 10. This 2 here is the greatest common factor of 2 and 12. Okay? This number 1 here is the greatest common factor of 5 and 12. And this 3 here is the greatest common factor of 12 and 15. Okay? So that's how we get the GCF, by using only the prime numbers going down here on the outside until we run out of factors to try to compute here. So that's the technique here. So the beauty of this technique is not only that, so instead of doing the prime factorization trees, we're doing it on the left-hand side. You can say big deal. But first of all, this normally takes less space, and it's normally a little more cleaner to write out, especially if you had bad handwriting like me. Okay. The second thing is that when you use this technique, you can figure out the least common multiple at the same time. And if you consider least common multiple has an L shape, like an uppercase L, if we do that by going like this, what we're going to do is multiply the numbers along that line. So 2 times 3 times 5, right? That's what we're going to do there. So it turns out that the LCM of 6, 10 is going to be 30. So if we go and look at the two criteria, and let me call them X and Y, because we don't want to get confused with that. So answer choice A, it meets Y, but it doesn't meet X. So that's no good. So we're going to do the same thing for here. Do the L shape, which means we're going to do 2 times 5 times 6. Okay? So that's 60. That gives us 60. All right? So that's what we're looking for. They want the least common multiple of 60. Cool. And the greatest common factor of 2. Okay? And then each number is less than or equal to 12. We already know that. Sorry, I meant this was X. All right? So it turns out that this choice is what we're looking for. What I circled in red is Y, and what I computed in the purple 60 is the X. Okay? So we have this thing here. This gives us 60 if we multiply those out. 1 times 5 times 12 is 60. But the other thing here is only a 1 and not a 2, so that's no good. And then the last choice, we have 3 times 4 times 5, which is 60, right? But it gives us a 3 and not a 2, so that's no good. So you can do this super fast by going through all the choices. One of the problems with 44 is that it's forcing you to do the LCM and forcing you to do the GCF of every single factor pair here. Okay? And it's pretty fast to do it. Again, I took 5 or 10 minutes here by trying to explain it out, but if you just zoom through it, it's really fairly fast to do. And even though I did this in my head yesterday while I was explaining this, you guys should avoid doing that, okay? I had somewhere to go after the session, so, but again, go look up my LCM and GCF videos. Okay, so 45 is almost like a punked question. I have a saying that the problem with the hard questions is they're so hard, and the problem with the easy questions is they're easy. And there's kind of a couple of tenets and weird pathology to both of those statements, which is that basically all questions can be deceptive and hard and tricky and all these other things. So it turns out that, again, I'm doing problems that most kids got wrong. So this one shouldn't be part of that. So we have to ask what may have happened here. So we have x plus 2x. So that clearly that's 3x. Okay? So the question is 3x plus what? Equals 5x. Okay? I suspect what happened here was a lot of kids said 2. Because 3 plus 2 is 5. But you have to put the x into it. So this is one of those things I think is not mathematically complicated here, but that it's about attention to detail. So this is an example like it's a pure silly error, a pure ridiculous silly error. That's my wild guess that what happened here. I doubt too many kids put B or D here. So my guess is that most kids actually put A without even really thinking that it didn't have the X on the end of it. And they didn't even bother to look at choice B, C, or D, because A just sorry, 3 I'm talking about, not 2. Wait, so I'm confusing myself now. Right, they got the 3 here, and they were just like 2 more is 5, and bing, bang, bang, they were done. Okay, so you have to watch out for that. Watch out for that. This is probably going back to a grade 3 level question, and yet most kids got it wrong. And that's the problem with some of these tests, including super hard tests. Now, generally speaking, the state tests are not super hard tests. And they're not necessarily throwing hard problems at you, at least not like the complexity of, say, the SAT or the SSAT. But in any event, that's the problem set that's out there. Okay? So when you finally do get a simple question that's just testing you on completely on core knowledge, that's almost a no-brainer, that's the problem with it. It's a no-brainer. It's shutting down your brain. So you have to have your thinking cap on, always. Your attention to detail must be always, right? There's no trick here in this question. And yet the majority of students who got this question got it wrong. So be careful. Because if you're getting this wrong, what are you going to do when it is really a hard problem? And your attention to detail is being all kind of sloppy, right? So be careful. Okay, we've seen this kind of a problem a few times already, which you should know already that there's a few ways to solve this. Without even reading the words, you should be able to know, oh, there's a shape here, right? We're going to look at the illustration first. There's a shape here that gives a bunch of dimensions. I have some idea that they're probably going to be asking me about an area here, okay, right? So let's look at it. They give me 6, it's in centimeters. They give me 10, it's in centimeters. They give me 14 over here, it's in centimeters. Everything is in centimeters, okay? So there's no unit conversions. So far you keep hearing me saying that. There's no unit conversions. On one of these problems, on one of the problems you're going to get, there's going to be unit conversions. So always be careful, because this could have said 10 meters at the bottom instead of 10 centimeters. So that's what you're always watching out for. And you can almost compute this, that the area of the whole rectangle, right? We're going to take a little sidebar, is length times width. And that's going to give us 10 times 14. And that's going to be 140. Okay? Everybody can see that the area of this whole rectangle is that. Okay? And then it's broken down into other pieces. There's the shaded area, I'll call A, or let me use, let me just call it uppercase A, and the triangle area, which is B. All right? So you might say, well, we can't figure out the area of the triangle because what's the length of this thing right here? Well, we know the length of that thing right there because this whole side here is 14. Then this whole side here is also 14, which means the length of this has to be 14 minus 6 or 8. Okay? Right? 8 plus 6 is 14, and that's the whole length. So the area of a triangle, we'll call it B, the area of triangle B is equal to 1/2 its base times height. You guys need to know these formulas. Just print out a formula page and just check them once a day for a month, and they'll be there in your brain forever. So this is going to be 1/2. The base is 10. The height is 8. So we get 80 over that, and it comes out to be 40. And I'm just going to double check I did that right. Yep. So the area of that is 40. Right? So we can almost see if the question is what's the area of the shaded area, it's just 140 minus 40, or 100. Okay, and we have some choices down here. 100 is one of them. We still haven't looked at the question yet. I'm kind of going on a few sidebars here. Okay. Okay. By the way, we can also figure out the area of shape A straight up. Because if you turn your head to the side, A is a trapezoid. A lot of you don't know the area of a trapezoid. So the area of a trapezoid, and I'll call it the area of A because that's what we're looking for, is the sum of the bases their average, so divided by 2, times the height of the trapezoid. All right, so in this case, this is our one base here, and this here is our other base. So we got a no-brainer. We're going to have 6 plus 14 over 2, right, times the height. This is the height. If that's 10, then this is also 10. All right, so we're exploring the areas of all the different shapes here in this sidebar. So that's times 10. So 6 plus 14 is 20, and 20 over 2 is 10. So we end up with 10 times 10, and that's equal to 100. So we have 2 ways to double check this. There's probably even other ways to do this. We could, if we wanted to, draw a line across here and figure it out from there. Because this is 10, this is 6. So the area of that this second half here is 60, right? And we already said the area of B was 40. That means this is 40. So then we're going to take 60 plus the 40 here, and we still get 100. So you have every way to the moon to double check this kind of a problem, if that's what it turns out the question is. All right, so now let's finally go look at the question. What is the area in square centimeters, so they don't change the units, of the shaded part of the rectangle? We already did it 5 ways. The answer is 100, okay? And by the way, just to get back to our numeracy kind of considerations, if we know the area of the whole rectangle, right, the area of the whole rectangle was 14 times 10, or 140, right? We wrote that here before, okay? And it's asking what is the area of the shaded part here, okay? You should be able to just visibly know that even though they don't draw these things to scale all the time in a lot of tests or a lot of questions that you get from your teachers or whatever, isn't this most of the area shaded in here? Can't you tell automatically that, well, especially if I draw this line like here, right, that more than half of the thing is shaded in? So the answer can't be B because 60 is too close, okay? I mean, sorry, the answer can't possibly be A, all right? The answer can't be B, all right? So 100's getting kind of close maybe, because if this was 50 here, right? If this here was 50, then you may not be able to figure out was it 100 or 140, all right? But if nothing else, you're left with a 50-50 chance at that point. And if you weren't sure of the formulas, by ruling out A and B, you could probably pin down what the formula was or figure it out, okay? Or at least deduce, you know what, I don't have to worry about this half of the problem anymore, all right? So anyway, we're using our skills of estimation and just our visual observation that we just ruled out 2 answers completely. That couldn't possibly be the answer, all right? Okay, you still left with 2 answers. You still need to decide it. But you went from 25% of getting the answer right to 50-50. Now, if this was a show your work problem, you may not get all the points, especially if it's all points or nothing. But at least if you wrote down on the side to the teacher that you could see that, you might get partial credit. I don't know. Depends how your teacher works and what the goal of the question is. All right? But you're trying to shoot for understanding the problem mathematically, observing the problem mathematically. That's what you're looking for here. Okay, you're not just following a rule book that says, follow this formula: area equals length times width. Well, what does length mean? What does width mean? All this kind of stuff like that. You're trying to piece these things together. You're not just following things robotically. Try to understand it, and that's when it starts clicking, and it even gets enjoyable at that level. Okay. Okay, so 51 is strictly a word problem. There's a couple of nasty numbers stuck in the middle there. Let's see why. Okay, so a sandwich shop sells sandwiches for $5.95 each. Okay, each, including tax. Is that important for to have written? Enough examples mention tax and it never comes into play. So let's see what happens here. So we're at the end of this thing. What did we learn here? That the full price of a sandwich, including its tax, is $5.95. Whoopsie-doo. The shop received a total of $71.40 from the sales one afternoon. Okay? So the total profit or the total income was $71.40. Right? Okay? Which equation, so they're not asking you to even solve anything here. Which equation can be used to determine the number of sandwiches sold by the sandwich shop that afternoon? So let's take our normal scenic route and we're going to go on a sidebar. If you're trying to figure out the number of something sold, wouldn't it be the total, right, over the price per unit, or we call that the unit price? Doesn't that give you the number sold? So if a sandwich was $10 and the price per sandwich, which is this unit price, was $2, doesn't that mean I sold 5 sandwiches? All right. So again, we're using what we know. We're avoiding the question for a while and taking a sidebar. And this is, I'm suggesting you guys actually do this. And again, we've seen this example where I've given before. Well, I just use simple numbers. Right? 10 is a good number to choose. That's divided by 2. It works out even. There's no decimal points. There's no fractions. There's nothing. Figure out what you're trying to solve mathematically, and then try to do an experiment and prove kind of that what the way you're looking at it mathematically makes sense. It's reasonable. It's sound. And do 1 or 2 test cases with it. Because sometimes you can do a test case and it works out. And it turns out that it's incomplete. There's more to the problem still. So be careful with this too. So with this in mind, that's our goal, that we're getting the total divided by the unit price. That's what we're shooting for here, guys. Okay? So a sandwich shop sells sandwiches for $5.95. So $5.95 is our unit price. Okay? The shop received a total. So this is what we're shooting for. Okay? To give us the number of sandwiches sold. All right? And you can even do an estimate here, like 6, the bottom is around 6 and the top is about 70. All right? So about 11 or 12 sandwiches were sold. The problem is they're not asking us how many were sold. They're asking us which equation can be used. Okay? And if you remember, as I talked about from grade 3, grade 4, grade 5, and some of these grade 6 ones, the equation they're going to come up with is not going to be the equation I just wrote here, that it's the total over the unit price. They're going to come up with some of the intermediate step or some other form of it. So in other words, if I have total over unit price equals the number sold, there's other formulas we can get out of this. For instance, if I multiply both sides by U, then the total equals the number sold times the unit price. All right? It's also true that the unit price is equal to the total divided by the number sold. Okay, there's a whole bunch of stuff we can do here. So all these 3 forms are valid. They all represent how to figure out the number sold. Okay, so what we need to now is look through these, because they probably put one of these tweaks to it to give the choices that we're looking for. Okay, so if you can't figure out how to map this right here into one of the 3 forms, you have to mathematically reason it out. So if X represents the number of sandwiches, okay, and let me circle that. I'll put it in red, so that it's leaping out at you. And this is something you should write. X is the number of sandwiches. Okay? So is it true in A that the price per sandwich plus the number of sandwiches is the total price? So let's say there are 5 sandwiches. Is it true that $6 plus 5 is 71? No. No, it's mixing units. $5.95 is the price, okay? This is the number of sandwiches. So we can't get a price out of that. This is addition. We're adding pencils and pens here. Okay, and that's not what it's asking us to do. So the answer cannot be A. Okay, B says the price per sandwich divided by the total price. No, this is upside down, right? Ours said it was 71.40 divided by 5.95. This is getting the reciprocal of it. So B is no good there. And it's logically no good. It's not the price per sandwich divided by the total cost of all the sandwiches. That's not the number of sandwiches, right? Okay, C. C says it's the price per sandwich times the number of sandwiches is the total price. Yeah, that makes sense, right? Right? If I had 1 sandwich, then the total cost would be $5.95. We decided before that we had 11 or 12 sandwiches. So $5.95 times, say, 12 would be equal to $7.140. So that looks like a good choice there. And then D says it's the price per sandwich divided by the number of sandwiches is $71.40. No, that's probably the worst choice of them all. So it's not the price per sandwich divided by the number. But if the price per sandwich was like $1, and I wanted to have 10 sandwiches, then that means the price per sandwich, that means that's equal to 0.1, not 71.40, right? So C wins for a few reasons, and it makes sense, okay? And C turns out to be this form right here. The total, which is 71.40, equals the number of things, which is X, times the unit price, which is $5.95. Remember, this is also the same as U times N. Because A times B is the same as B times A. Yay, right? Okay, this problem teeters into what's called probability and statistics. It's kind of its own branch of math, and it ties into setting things up as a table and just breaking your things down. And like I said in some of the other examples, I like when the question is in the form of a statement and the bullet things, because then I can kind of proceed through the bullets in a logical fashion. And it's almost spelling us out the order that we should go into. Although the bullets are not necessarily in ordering, but often we can use them for that purpose. And I almost wish all problems were this way. And what you should be doing with all word problems is mentally twisting it into a shape like 15, right? Because that's about problem solving. How are we taking these sentences and ripping them apart and trying to make cognitive, logical, and mathematical sense out of them, right? So let's jump into this bugger. All the students in the 6th grade either purchase their lunch, and don't let that this says 6 throw you off like, oh, the number 6. They're just talking about a grade. It could have been grade blah, 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 blah. We don't care, right? Don't let that fact that there's a 6 there throw you. Unless it's going to say, like, we're going to subtract grade 11 from grade 6 and grade 5. This problem isn't going there, okay? They're not asking you to do anything with the grade number itself, okay? All the students in the 6th grade either purchased their lunch or brought their lunch home on Monday. So what is going on there? They're telling us there's a universe. There's a universe here. And we know there's a universe because it says all 6th graders. All 6th graders. So we don't care about anybody else. We only care about 6th graders. And it's telling us out of 6th graders, okay, they all either purchased their lunch or brought it. Yeah? Reread the sentence and make sure you see that out of it. All of the students in 6th grade either purchased their lunch or brought their lunch. for home on Monday. They're not talking about any other day. So this is 6th grade lunch. On Monday. Okay, we don't know yet whether other things are going to be talked about beyond lunch. We don't know what else is going to be talked about beyond Monday. But the pattern style for this question is most likely nothing else is going to be talked about. Okay? So let's go and see what's happening. It says 24% of the students purchase their lunch. So let's fill that in. This is 24%. 24 over 100. Okay? So if 24% of the students purchased their lunch, how many didn't? And if they didn't purchase their lunch, what did they do? We know what they did. They told us all of them either purchased it or brought it. So they must be in this category here. So it's 100% minus 24% gives us what? What do we get there? 76%? Right? So about 25% bought it and about 3/4 didn't buy it. Okay? Now it's telling us 190 students brought their lunch from home. That's here, 190. How many students are in the 6th grade? Whoa. So this is the point where it blows everybody's minds. Okay? If we total this column here, going down here, we get 100%. Okay? What about if we total this column here, which is the number of students? We don't know how many purchased it. So let's call that X. That's X. So the total number of students is X plus 190. Okay? Unlike the example we just did, they're looking for an exact number. They're not looking for an expression in this, for this example. So how the heck do we figure out what X is? How can we possibly figure that out? Enough of you are going to say there's not enough data here. They're not giving us enough information. But we know the ratio, that's 76%, represented 190 students. Okay? So then that means 24% of the same total, whatever that total happens to be, is X students. And then all we have to do is the cross product. Because these two ratios are equal and we have set up a proportion. So the problem gave us all the data for B, for the kids who brought it, but only half the data for the kids who purchased it. So we're going to use that to our advantage. All right? So we have, we're going to do the cross product. So we have 76 times X. Equals 190 times 24. Right? We're going to cross these two, do that, and then do these two. And now to get X by itself, we're going to divide by 76. Okay? We can get rid of that then. All right. So now what we have left is a nasty multiplication. That's what we have left. So you can do 190 times 24 divided by 76 and be left with doing a whole bunch of computations. We could try to see a way to simplify this. Let's start seeing if we see anything common here. 3 goes into that. No, two certainly goes into some of the things. Nothing's leaping out at me, so let's use 2. 2 goes into here 38 times. And 2 goes into here 12 times. Did I do that right? Yes, I did. Nothing's still leaping out at me. So 2 goes into here 19 times. 2 goes into here 6 times. 19, whoops, let me write that 6 right. This tablet is never writing 6 right. Let me fix that for you guys trying to follow this. So 2 went into the 38 19 times. And 2 goes into the 12 6 times. So we're left with 190 times 6 over 19. 19 goes into 19 once, and 19 goes into here 190 10 times. So this comes down to 10 times 6, and that's equal to 60. Okay, so if I did this right, since x is 60, we're going to come back over here and get 60 plus 190. And that gives us 250. Okay, which is choice D. All right, so there's kind of a lot of steps here, but it's still following a pattern. So we just go through the sentence, especially when they use always, or there's some things where they flip this, where they say never. And what you're trying to do is build a chart and categorize this and figure out exactly kind of what you're shooting for. All right, and you can also double check this, because if you get 250, you don't know if it's right or not. Okay, so you could do something like 24% of 250 and see if you get the 60 back. If you get the 60 back, they're telling you already the 190s are there. Okay, so there's ways to do that. All right, and so now that we know the actual answer and that we had to add 60 to it, that means our table, just to write the table a little more cleaner again, I'm going to rewrite the table down here. Let me just make sure it's showing up in you guys' screen. Yeah, it is. Okay. So we're going to have the 24%, the 76%, the 60, and the 190. Okay, so I said before, 24 is about a quarter, and 76 is about 3/4. So does this 60 and a 190 make sense? They gave us this. So could we have not even almost estimated that 60? Right? If 3/4 of something is about 200, isn't there about another 50 to it? Right? If 3/4 of something is 200, about 200, then another quarter is going to be about 50, give or take. Okay? Right? Another way to look at it is 25% of something has to be the other number. And when you think that through logically, you're going to end up with D. Really, what you're trying to, because this was X originally, right? So we need to go through another step, which is do the addition we did here to get to 250. So what we're really looking for is the 25% number here at the moment, right? Yeah? So you should be able to see that leaps out at you. That it's about 50, 60, 70, that kind of a number, all right? And that you need the 60 there to do it, right? Because the difference here is only about 20. And the difference here, it's smaller. It says how many students are in the 6th grade. It told you 190 brought lunch. So how could there only be 166 students? And how could there only be 76? So A and B are out the window no matter what. They almost gave this to you on a silver plate. Now, enough kids probably may have decided, we calculated that the number of kids who paid for the lunch was 60, but some kids may have figured it out by estimation that the number of kids who brought it was 76. If you did that, that's a good guess. Turns out that's not what the question is, though. All right, so be careful with this stuff again. There's all the math going on. There's the logic. There's the thinking. And there's actually answering what the question is asking you for, right? And that's part of your analysis. That's part of your ripping these things apart. Okay, let me just make sure we're live and there's no questions. I see a few people out there. If you have questions, please ask. I'd like this to be interactive. Please subscribe. Please press the like button. If you guys have any questions or need tutoring or whatever, definitely feel free to email me on this. If you're catching this on the replay, you can pause it before I start a problem and then see if you get the same answer and listen to how I show often all the alternatives, the way to solve these things, okay? Okay, 16 again is a totally different kind of a problem. And we like to look at the illustration first. And the problem with looking at the illustration first, there's kind of two levels of illustrations. The first problem is, this is our illustration right here. Whoops, it lost the pencil for some reason. That D equals 4T, right? And in your mind, you should be thinking of D equals RT. Distance equals rate times time. Is that what they're asking us for here? I don't know, but that's a good wild guess, right? Remember, a lot of these questions, they're not really trying to be esoteric. They're not really trying to trick you. There's no numbers here in all these 5 live streams or whatever that were really where you got an answer like 1.67 or pi divided by the square root of 2 or something like that. They're really trying to test you on the concepts of it. Okay? There are harder test questions that test you on other things. But these questions are oriented to test your raw knowledge, your core fundamentals, and things like that, even though they're still requiring you to think. There are harder tests that test other skills of yours. Okay? These questions are just designed to make sure that you're on the ball on the core fundamental stuff. And from there, you can build up and work on the harder problems, okay? But it still doesn't mean it's not consistency. So when I say D equals 4T, in the back of my mind, I'm thinking, oh, D equals RT, and therefore R is equal to 4. This is some sort of speed problem or something like that, okay? We're still not done by looking at the illustrations, though, because it turns out that every answer choice gives us a coordinate geometry grid. Okay, so let's look at those and see if we can grok anything out of those. So the x-axis, which they're calling t, which might represent time. Ooh, it says time in hours. Okay, so that's what we're going to look at. The left-hand side is distance in miles. Okay, and that's not y in this case, it's d. So this is not an x-y coordinate geometry grid. It's a TD coordinate geometry grid. Okay. There's nothing funny go on with what they charted. It goes 2, 4, 6, 8 on the bottom and 2, 4, 6, 8 on the top, and it skips boxes. So every box is a unit here, and this week just seems to make sense. Okay, choice number C is next to A, and it seems to have the same stuff. It has the horizontal is T, the vertical is D. It goes 2, 4, 6, 8. That's unit thing. The bottom's called time. The left is called distance. So let's see if that's true of all the others. Yes, it is. Okay. We can look at a bunch of these, and we notice that they all have different slopes. C has probably the most consistent slope because if you notice, there's a square there, and it's going through the middle of every single unit square. All right. So that might be helpful for us to know. I don't know yet if that's going to be important or not. Okay, because we haven't looked at the question yet. And also we can make a note that D, its graph goes straight up. So there's no slope on D at all. So is that what they're going to ask us here? which of these is the equation of a line maybe, or something. We don't know where they're going here, right? And the steepest slope is D, the next steepest slope is A, the next steepest slope is C, and the least steep slope is B, right? Think about your driveway. That's not really a steep slope. Whereas choice number A, you better hope your driveway doesn't look like that. You better hope it doesn't even look like C. And you better definitely hope it doesn't look like D. So B might even be even too strong an angle for a driveway, but that's what we're talking about here with the slope, right? Otherwise it's flat. Otherwise you're horizontal, all right? So if they're asking, they might be asking a slope question here, or they might just be asking us something, because I'm noticing something else, that they put a dot on everyone. And since I cluttered up choice number A right now, I'm just going to circle it. They're putting a dot right there, okay? And they put a dot there, and they do it on each one. So this is, again, your sense of observation, that you're trying to just understand what they're showing you first, so that when you get to the words, you don't let the words start distracting your brain, okay? Because that's part of what's going on here. Different part of your brains are activating when you're trying to solve a problem. You have visual and you have topological stuff going on. You have computational things going on. Even artistic stuff might be going on in some of this, right? And then there's stuff like where it says that D equals 4T, there's an equation. So your brain is just going wild at this point. All right, now that we ripped apart what we're seeing, let's finally go and look at the words. Joe walks on a treadmill at a constant rate. Joe's a great guy, right? The equation below describes the relationship between T, the time he walks in hours, right? And if you go to graph A, that's kind of what it's showing here. So that's confirming that T is the time he walks in hours. He's on a treadmill. He's not running. He's not jogging. He's just walking for a certain amount of time, okay? And D, the distance he walks in miles. So if we just try to do a thing here, it shows us that in 2 hours, he walked 8 miles, okay? In 1 hour, he walked 4 hours. So each chart kind of has that same thing. But the funny thing is chart D doesn't really have it. It's saying in 4 hours, he walked everywhere. Like what? In 4 hours, he went 2, he went 3, he went 4 and 5. There's no D here. There's no distance. He's just walking to infinity in 4 hours. So that doesn't make logical sense. So we don't know if that's what they're going to ask us, but let's see. So in addition to that, they've also given us what we already talked about, the D equals 4T. So which graph represents the relationship between the amount of time Joe walks and the distance he walks? So this is no longer just D equals RT, it's D equals 4T. So if we plug in 1 for T, right, if we create a table where that's T and that's D, if T is 1, then that means D is 4, because D equals 4T. If D is 2, then D is 8, okay? If D is 3, if T is 3, then D is 12, okay? So this part should be no-brainer to you guys. It should be making obvious sense, totally not confused, right? So which graph represents the relationship? That relationship, this one right here. So all we have to do is see which of them one of those matches this table that we did. Okay, so let me get rid of my clutter on choice A so that we could actually see if that is indeed what's happening here. So 1 matches with 4. Yeah, it does. Okay, 2 matches with 8. Yeah, it does. Okay, so choice A looks like it's it. So let's just confirm by going to C. 1 No, 1 matches with 1, so C is no good. Okay, this one here seems to match with a third, so B is no good. And 1 here, it's not even on the graph, so D is out. All right, so for that reason, our answer is A. So this question was super busy with a lot going on, and really almost none of it mattered, okay? Now, I say that lightly because you do have to understand coordinate geometry. You do have to understand the words. You do have to understand the equation they gave, all that kind of stuff like that. But when it's all lined up, you're set. You're good to go. All right, looks like we might get to finish these today. Why is there nothing on this page? Here we go. Okay, 22 is a weird one, and I can almost see why it throws off a lot of kids. Let me just make sure we're live and everything's set up right. So I hate to go for another half an hour when it turns out that things are not set up right. Or my microphone was off or something like that. Okay, a shape is made of 12 right triangles. Okay, what's a right triangle? It's a triangle where one of the angles is a right angle. Whoopsie-doo, right? There's 12 of those. It doesn't tell us so far how they're set up. Each right triangle has a base of 4 and a height of, whoops, I erased that. What does that say, 5 or 3? 5. And a height of 5. Okay? What is the total area in square centimeters of the shape? A lot of kids are going to get thrown off because they don't know what the shape looks like. And the truth of the matter is, all we're going to do is we have this shape that's just, I'm going to draw circles at the moment because we don't even care how it says. It just says it's all pieced together, right? So let's get rid of the circles for a second and work, purely with the right triangles. And just to show you, I won't do 12, but let's say it was 3 of them. We could do that, and we could do this. Okay, we could do another one where you put the second one here, right? And then the third one here, right? And then the fourth one here, and so on. There's just so many ways to do this. I could put the thing like this and put another one here, right? And just whatever. What's important here is that there's 12 of them. 1, 2, 3, 4, right? And I could have combined this one to this way even. What is 1, 2, 3, 4? So in this case, there's 12. So doesn't it seem to be that all we have to do is 12 times the area of this right triangle? I'm going to call it little RT. Isn't that what we're shooting for here? Right? So let's reread the question. Let's make sure. Let's see if our strategy and our experiment would make sense. A shape is made of 12 right triangles of equal size. Cool. Each right triangle has a base of 4 and 5. Cool. What is the total area of the shape? If the shape is all of them added up together to this giant shape made of composite pieces, and each composite piece is just the right triangle. Isn't it 12 times that? Yeah, it seems to be. So the area of a right triangle is 1/2 base times height. So we're going to get 1/2 times 5 times 4. We get 5 times 4 is 20 divided by 2 is 10. There's a couple of ways to do that. We could have canceled this 2 into the 4 and still gotten 10. Okay? So the area of this is 10. So if there's 12 of them, we're going to have 12 times 10. And bam, 120. Okay? I'm not sure why most of the kids got this question wrong. It seems fairly straightforward to me. I don't really see a gotcha, and I have a feeling the kids didn't really understand how to combine the triangles. And the answer to that was, it doesn't matter how you combine them, right? I don't see how they did that. Obviously, the 240 is twice of C, and the 60 is half. Otherwise, I don't know where things are coming from. I would have thought they would have given 5 times 4 as one of the answers, which is 20, but I don't see it there. So I would really have to sit down with some of the kids on this one for sure. This one is a little aloof to me about how this may have happened. But that's just do it straight up. There's 12 shapes. The area of each is 10. Oh, sorry, that's where they got the 10 from. Okay, but anyway, the answer is C. So they did what's the total area of a shape of one of the triangles, but it says the shape is 12 right triangles. The shape isn't one right triangle; it's 12 of them. So be careful. I have a feeling that's not why kids got this problem wrong, and it could be for a multitude of reasons. All right, let's go on. We have maybe 3 or 4 more questions. All right, so we have a semi-busy problem again. We have a coordinate graph, an XY graph. It's labeled 1, 2, 3, 4, 5, 6, 7. The left side goes from 1 to 7. There is no title for this, which is fine. There are 2 coordinates, 2, 4, which is the school, and that's 6, 4, which is the bank. Okay. I'm guessing they may ask me for the distance. So this is 1, 2, 3, 4. I don't know what they're going to ask me, but that's just all I can do. Sometimes we saw the other example the other day where they were asking for something just as far away from it. So if they were asking for something just as far away as the bank was 4, let's say it was on the same line, we could go over 1, 2, like a second bank could be over here. But that's out over the grid. So in that kind of example, we would be trying to do something like this, right? And then basically all the stuff here, give or take, especially if it's far away, would not be part of the answer choice. So this is just my scribbling on here, just to give you kind of a heads up. We don't know what the question is yet, so let's get rid of all this stuff. Just giving you variations on the question. All right, so let's go back to the words because they're not really giving us much there. Mark graph points on the coordinate plane below. Yay! They represent the locations of a school and a bank. All right, so this is not anything out of the ordinary. Mark wants to add the location of the library on the coordinate plane. The distance from the library to the school is the same as the distance from the bank to the school. So that was basically the circle I just drew. So if the bank was 4 away, that means it could be here, it could be here, and within that radius of that circle, if we fake drew it, and we're doing this freehand. So if it turns out what they're going to give us is over here, we know it's not valid. If it's here, it's valid. It's invalid as well. We don't want something very close to this line. So if it's here, we're going to have to calculate it. So let's see what the choices they give us are. They say it's 2, 4. Okay? So if the library was a 2, 4, is that the same distance from the bank to the school? No, it's on top of the school. It'll be on the next level of the school or below it, right? So it can't be choice number A. Okay? Let me get this right. It was not showing on the screen. Good. Let me make sure the D is still there. Give me 1 second. Yeah, the D is within the line. Okay. So A was no good. Okay, B says 2, 8. Yeah, 2, 8 sounds like it's it. Because if the school was 1, 2, 3, 4 away, and I go 1, 2, 3, 4 straight up, then that's 2, 8, and that sounds good. So I like it. But let's look at the other choices. 4, 4. 4 is here. Okay, that's only 2 units away. That's half the distance between it. It says the library is the same distance between the two. So that's no good. And the last choice is 6, 8, which is way outside of our circle. Okay, but if we wanted to kind of draw a line to there, okay, we can see that's not the case. This is 4, this is 4, and it turns out the purple line here is longer than 4. In fact, it's 4 times the square root of 2. And I'm going to leave that as an exercise for you guys to figure out where the heck did I get the square root of 2 from. Okay, but if we draw a right triangle, then we use the Pythagorean theorem, which is c squared equals a squared plus b squared. That's what we get. We get 4 squared is 16. 4 squared over here is 16. We add them together and we get 32. And the square root of 32 turns out to be 4 times the square root of 2. Okay? And then this is our answer here is B. Okay, the coordinates of the point of a rectangle. And our illustration is P, Q, R, and S. So what we're going to do is do this freehand. Let's try to use the space here. What I'm going to do is, since all these are positive, okay, instead of doing this, because we're only worried about what's in here, okay, I'm just going to do that over here so that it's large enough. Okay, this is our X. And normally you can get points off, especially when you show your work, right? These are rays, and you're going to label your X and Y. Some teachers take off of this. This is multiple choice, but I'm just trying to cover all the options. This would be 0. So the points here, none of them pass 6. So I'm going to kind of just go 8. So if that's 8, then that's 4, right? Then that's 6 halfway between the two of them. And then that's 2. All right? And then obviously that's 1. Half of that is 3. Half of this is 5. Half of that's 7. And that's back to our 8. So let me try to, this is about the same thing. So this was 8. Half of that is 4. Half of that is 2. So this is 1. This is 3. And if you notice, there's a lot of time, if that's 8, spent on this problem actually drawing this silly thing. Okay, that's 5. And that's 7. Okay. And on a test like this, they might give you scrap paper, but they're not going to give you graph paper. You're in your class, however you're solving this, you might be. So let's do this. 2, 2 is P. Okay, I don't know where this is going, so often it's better to do this, to actually write it there. And I scribbled on it, so let me erase that for 1 second. Make sure that we're actually looking at what we're supposed to be looking at. So this is 2, 2. That's P. Q is 6, 2. Okay, so far, if we drew them and connected them, that's certainly a straight line, and maybe this is kind of going to go like that. I don't know, right? So let me get rid of those dots just to show you that's what we're doing. So Q is 6, 2. R is 6, 5. So that's about right here. And S is 2, 5. All right, so this does line up. Wait, sorry, 2 was over there. This is S at 2, 5. If we connect it, they will both be horizontal and vertical lines, adjacent alternate horizontal lines, and that is a rectangle then. So then it's going to ask us, what is the perimeter? All right. So let me go and do this again. Q is 2 comma 2. Wait. I said that wrong. Let me change the color of the pen. Okay, this here is 2, 2. Q was 6, 2. R is 6, 5. And S is 2, 5. So you should be able to see that since this line is 6, 2 and 6, 5, that the length of this is 3. And we can confirm it over here that this goes from 2, 2 to 2, 5. So this is also 3. And since it's a rectangle, that works out. That's cool. All right. Now if we look at this line, this one right here, that's 2, 5 to 6, 5. So the length of that is 4. And this one here is 2, 2 to 6, 2. So that's also that. So the perimeter is going to be 3 plus 4. Right? Plus 3 plus 4. So we should get 14 there. And we get C. All right? So the problem with this one is actually drawing it out and drawing it out neatly. Okay, here's another one that almost might be too simple. There is a slight gotcha with it though. So what we're going to do first with this is we're going to combine like terms. This is our 2 like terms. So 60 minus 9 is 51. And 3y still stays 3y. So enough kids then get bent out of shape at this point. They don't know what to do. But turns out that there's still a factor here. If you notice all these choices, they're kind of using the distributive property. And remember that was, it's A times B plus C. Right? And that's equal to AB plus AC. And it's also A times B minus C. Okay? And many of you used to, even if we take this 51 minus 3y up here, many of you are used to seeing this written this way. Okay? This form here is the kind of standard form, but there's nothing mathematically wrong with this version of it. All right? So if it's easier, morph it into this way. And at this point, do any of these choices leap out to you then? Okay, and one problem with this is that a lot of you guys don't know how to do factoring, and you don't know your multiplication tables. So a lot of you learned it up to 10 by 10 or 12 by 12. But you should really learn it up to 20 by 20. And it turns out this couple of numbers like 16 times, 17 times, 18 times, and 19 times, especially multiplied by 2, 3, and 4. Those numbers often come up, especially the 17 and 18 kind of thing. And especially numbers like 51 and 57. A lot of you guys think 51 and 57 are prime numbers. They're not. They're just ugly numbers that are tiny. They're not prime numbers. They're both divisible by 3. All right? They're both divisible by 3. So if we map this here, this minus 3y plus 51, that means when you get 3 goes into minus y, right? Because 3 times minus y is minus 3y, plus and 3 goes into 51 17 times. So this is really the gotcha on this problem. That a lot of you guys don't know what to do with the 51. Even in problems that are not relating to the distributive property. You just think if it asks you prime numbers, or you have to get the least common multiple of something, you guys don't realize that 51 has factors. It just looks like it doesn't for everybody. Okay? So what you need to do is learn your divisibility rules. Right? If you don't know that 51 has factors, then learn your divisibility rules. Like a lot of you guys know that a number is divisible by 2 if the rightmost digit, the ones digit, the ones place value digit, is even. There's rules for divisible by 3, there's rules for divisible by 4, there's rules for divisible by 5, and so on. Like the rule for divisible by 3 is to take the digits, in this case 51, add them up together. In other words, 5 plus 1 is 6. Is 6 divisible by 3? If the answer is yes, then the whole number, the whole original number, is also divisible by 3. There's a couple of nuances to the rule, but that's the most simple version of the rule. If you add up the sum of the digits of a number and they're divisible by 3, then that whole original number is divisible by 3 as well. All right? So that's how you know 51 is divisible by 3. And you can do this in your head in microseconds. Okay? And if it's not divisible by 3, there's other scenarios. Like you know if a number is divisible by 10 because it would end in a 0. You know if a number is divisible by 5, it ends in a 0 or a 5. Okay, there's other rules for other numbers too, right? They're not as easy as 2 and 10 and 5, but that's already 3 of them, by the way, right? There's only 10 choices here. So if you know 3, you already know a third of them. So it's not hard. Again, if anybody wants information on how to do that, I normally provide this to my students. Please email me, and I will send you the document on what the divisibility rules are. All of you should have learned it in your school. If you haven't, complain to your teacher. We're doing grade 6 right now. You would have learned it before grade 6. Okay? And again, this deals with your numeracy and fluidity. So you're taking numbers. There's so many ways to decide whether 51 has factors or not. And in grade 6, you should know that already. All right? All right, we have about 2 more questions left. Let me just see if there was anything there. So number 1 is the answer. Because once we get this in this form, right, there's no answer that matches that. So if we flip the 2 of these, because a plus b is the same as b plus a, then it's the same as 3 times 17 minus y, okay, which turned out to be choice A, all right? So that's how we finally get the answer there. Okay, so 27 is almost straight up arithmetic. Okay, the volume V of any cube with a side length S. So we have a cube. We're going to visualize it. The length of its side is S, and since it's a cube, by definition, every side here, including the ones I didn't draw, is S. And the way we get the volume of a cube is V equals, it's normally length times width times height of a rectangular prism. A cube is a special kind of rectangular prism. So it turns out the length and the width and the height of a rectangular prism is all the same length. So if we just call that S, that's how we get S cubed. Right? Because if you ever realize, when you take the area, you get square units. When you take the volume of something, you get cubic units. So if L is the same as S, and W is the same as S, and H is the same as S, you're getting S cubed. Okay? So they're saying, what is the volume of the cube length if the side is equal to 2.3? So here's what the problem reduces down to: 2.3 cubed. All right? So what could the answer be there? And by the way, to be clear, choice A is 5.29. Choice B is 6.9. Choice C is not 8,027. It's 8.027 or 827 thousandths. And 12 is not 12, D is not 12,167. It's 12.167 or 12 and 167 thousandths, right? So let me just put that down. This is 12 and 167 over 1,000. Okay? This is not a comma, it's a point. So be careful when you're looking at your test papers or your problem on your screen or your Khan's Academy, whatever you're looking at, you need to do. Just make sure you're being clear on that. All right? So what we actually have to now do is go sweat out, because this means 2 in the third, or 2.3, sorry, times 2.3 times 2.3. All right? So shall we do that? And hopefully I do not make a mistake. Let me try to write this as neat as I can. So 3 times 3 is 9. 3 times 2 is 6. 2 times 3 is 6. And 2 times 2 is 4. So we add those up and we get 9. 6 plus 6 is 12, 2. Whoa, what did I just do there? Something happened. Actually, let me shift this up because I'm at the bottom of my screen for some reason. We get 6 plus 6 is 12, carry the 1. We get 529, and we have to accommodate for 1 decimal here and 2 decimals here. So we get 5.29. And then you're going to multiply that by 2.3. Right? We got rid of that one, and we still have this one left. All right? So 9 times 3 is 27. Carry our 2. 3 times 2 is 6, plus 2 is 8. And 5 times 3 is 15. Okay? 9 times 2 is 18. Carry our 1. 2 times 2 is 4, plus 1 is 5. And then 5 times 2 is 10. So if I did this right, this should be our answer. So 7. 8 plus 8 is 16. Carry. 5 plus 5 is 10, plus 1 is 11. 1, 1, 2, and then 1. So we get 1, 2, 5, 6, 7. And we're going to move over 1, 2 decimals, plus 1 more, 3. So we're going to go 1, 2, 3, and we get 12.167, which is this answer here, number D. Okay? So now that we sweated this through, it turns out that you can get the answer quite reasonably fast. Okay? If you did, let's go halfway. If you did the 2.3 times the 2.3 and you got the 5.29, you already ruled that A and you've ruled that B. You already know if it's 5.29 times 2 point something, the answer has to be over 10. So C is no good. So you're already at D. Okay? So let's even go even more abstract off of this. If we ignore the decimal point for a second, let's go through 2 scenarios. That it was 2 to the cubed. Okay? That's equal to 8. All right? 2 to the cubed equals 8. So let me change the pen color. That again rules out A and B. Okay? Do you think that 0.3 is only going to do the 0.27 there? Or will it be more? So some of you may not know, but at least you ruled it down 50-50 now. For those you know, it can't possibly be C. Okay, the other choice is that if we round the 2.3 up to 3, 3 cubed is 3 times 3 is 9, that gives us 27. That's a huge number. So you can almost see, whoa, this escalated real fast. All right? But at least you have a little heads up. You almost know that it can't be 8. You definitely know it's not A or B no matter what scenario you look at this with. And for those of you who sit with the problem a little more, if you know 2 cubed is 8, then how could 2.3 cubed possibly be 8.027, right? This is 8 and 27, and that's over 1,000. It's not even hundreds. So 27 over 1,000 is a pretty tiny number. So if 2 to the third is 8, then how could 2.3 to the third possibly be 8 with a little tiny number after it? It's got to be bigger than that, okay? And in fact, when we actually compute it, we realize it's a lot bigger. It's 12, right? It's 50% more bigger still, or larger, okay? And we have finally the last problem. Hooray! And it's another one where we can see the choices as I shift this over. They're not asking us to compute something. So what are they asking us to do? Ken and Tammy are making necklaces. Awesome. Ken makes 25 necklaces. Super awesome. Tammy makes M more necklaces than Ken. Okay, now we're getting slightly confusing. What are they talking about here? Ken made 25, Tammy makes M more? What? Okay, so let's just stop and try to understand this. Ken and Tammy are making necklaces, so that's just feeder info. There's nothing really mathematical there. Ken makes 25, so Ken is a 25 necklace maker. Okay, Tammy makes M more than Ken. So isn't it true that she makes 25 plus M? I mean, sorry, wait 1 second. I didn't mean to write that. That Tammy is Ken plus M, right? Which, by the way, depending on how they show this, is the same as M plus K. We don't know what form they're going to show this into as yet. Okay, is that not the interpretation? So let's go through it again. Ken and Tammy are making necklaces, cool. Ken makes 25 necklaces, check. Tammy makes M more than Ken, check. Okay, which expression represents the total number of necklaces that they both made? So now isn't, well, I use T for Tammy, so I'm going to use N, and I might put a little C. Total number equals what? It's the number of Kens plus the number of Tammys, right? So is that not 25 plus, and I can parenthesize it just because that I see there's a paren in one of the choices, and that might be where they're going, K plus M? Okay, so let's see if any choice matches that. D doesn't seem to do it, C doesn't seem to do it, B doesn't seem to do it, and A doesn't seem to do it. Yikes. How does that help us? So if you remember, I've explained in all of these that the answers they give you in will not be the form that you end up with. So there's either a step before that or two that they throw at you, or sometimes it could be a step after. Let me just fix this and make this cleaner, because that's a little M right there. Okay, so what do we do here? We know that K is 25. So how about we substitute it in there? Okay, so then we would get 25 plus, and then we're going to parenthesize it just because 25 plus M. Okay, that now definitely matches A. Does it match B? Is it 25 plus 25 times M? No. No good. C is 25 plus M? No. 25 plus M is actually nobody's choice here. And D is 25 times M. No, that's no good. That's no good. Right? So the answer here is choice A. And if you logically go through some of this, you can even double check that that's the case. So let's work backwards with D, right? How could M, Tammy makes M more than Ken. So it didn't say she makes 25 times more than Ken. She just makes M more, not times more, right? If I have a pencil and I want to add 2 pencils to it, then I have 3 pencils. That's not the same as doubling it though, right? So that's the problem with D. Okay, C says 25 plus M. So Tammy makes M more than Ken. Well, that's Ken's. The 25 is Ken's, and then she makes M more than Ken. But what about the 25 that Ken already made? So this should really be plus 25. So that's no good. And then B is 25 plus, which is Ken, plus her. But again, the problem with this 25M is the same problem we had with D. That's not saying she makes 25 times more. She just makes 25 units more, plus 25. So B is no good either. And then A makes perfect sense. This is Ken, that's Tammy, and we can add them together. Of course, the answer could have been 50 plus M, right? If we simplified it, if we combined the expression. That's a possibility there. It could have been 25. We could have flipped the 2 of these, right? So that's some of the choices there as well. All right, we're done. Let me see if there's any questions out there. All right, it's a quiet group today. All right, it's a Friday. Hopefully everybody has a good day, good weekend, and I will start the grade 7-1 at some point. I'm not sure when. And again, if you guys have questions, always free to ask me. Please subscribe, please like, please email me, please make me your tutor. All right, guys, peace out. Have a great weekend.